Hello everyone, welcome back to my channel Technish, where we simplify Kotlin and we make it exciting. So today we are diving into an exciting and advanced concept in Kotlin, that is domain-specific language. It's a very interesting thing. Learn with me, and we will make it. We will try to create some real-world examples. Okay. So Kotlin DSL is a powerful feature that allows you to create intuitive and readable and flexible code for specific problem domains. Okay, so suppose you have some of the specific domain related problems and you have to use some domain specific names to resolve your problems. So you know Apex, right? That is a Salesforce domain specific language that is specifically based on Java. So that's like the way you can create your own domain specific language. Okay. For any other, like if you have worked in CRM related stuffs, so you will get to see there where domain specific language like special syntaxes for those. It's like you know that this is based on Java, but you cannot use the exact Java syntax. Rather than that, it's an abstraction over the actual Java. Okay, so whether you are working on build tools like Gradle, creating APIs or designing custom configurations, Kotlin DSL can make your life as a developer so much easier. By the end of this video, you will not only understand what DSLs are, but also know how to create your own DSL in Kotlin. So grab your coffee, let's dive in. So what is DSL? I mean, first start with the basics. It's a domain specific language, just like the way previously I've told you. Okay, it's a syntax tailored to a specific domain. Okay, for example, Gretel uses Kotlin based DSL for build scripts. Instead of writing verbose Java code, you can use Kotlin's concise and readable syntax to define your build configurations. So think of a DSL in a way, to make your code more, like natural language. It's more readable, expressive, and purpose built for a specific task. Okay, Kotlin is particularly suited for DSLs because its features like lambda expressions, extension functions, and the other stuffs. Okay, so you need to understand first that why we use Kotlin DSL. Okay, so now you might be wondering, why should I care about DSLs? Like, so first you have to understand it gives you good readability. Okay, it makes your code so much natural and self-explanatory that you don't need to write so much verbose things. And you for this one, the another advantage is flexibility. You can define rules, structures and commands, specific to your problem domain. The problem that you're solving, suppose Salesforce is solving their problem related to the CRM domain or the cloud domain. In those cases, you don't need a verbose Java code. All you need is a tailored syntax so that it can solve that problem for that domain only. Okay. And it reduces the boilerplate codes that you don't need to write so much code. Okay. So a great example of Kotlin DSL is Gradle build scripts for creating custom UI DSL applications. Or imagine writing UI layouts in Kotlin instead of XML. Okay. So first, let's create a simple Kotlin DSL to build a pizza order. Okay, we will go do that. Let's go to editor. Okay. Now let's define a class. Okay. Suppose I will define pizza and I take a private variable toppings, and I will take it as a list because it can be, there can be multiple toppings, right? Mutable list of, and the type will be string. Okay. Suppose, and we take another one that is size. Okay. This size will be also a string. Okay. And by default, we will define it as a medium. Okay. Yeah. Now, what I'll do is I'll create a size function. Okay, there the size I will define as a string. Okay, and I will do is this dot size equals to size. It's a simple thing. Okay. Ah, okay. Sorry. It should be aware because we are initializing the variable here. That's why. Okay. Now let's try to append something to the toppings. So we will do append topping. Let's take this topping as a string, and in the list that we have created, toppings dot add, we will do is topping. Okay. Now whenever now we have we have created two variables, and we have first one we have initialized the size, and after that we are appending the topping in the mutable list that we have defined. Okay, now let's create a build function that will we will use it to build a pizza class. Okay, and we will return what we will return is the formatted string. Okay, and we will define size equals to, we will do the interpolation here. Okay, and what I'll do is, and the toppings equals to toppings. Okay, let's close it. Okay, okay, so it is done. Now what I'll do is I'll create you know a DSL that will allows the methods like size and add to toppings for intuition code. So for that, what I'll do is I'll create a function called pizza, and in the builder I will take, so this is where you define the pizza dot, and it will, the return type would be, I mean, the derived one will be unit, and the return type will be string. Okay. So first understand this, what I've done. It's just like the way, we have defined, okay, we have defined a function called pizza, and in the builder, okay, in this builder specifically, that is the variable that we have defined. And in the builder, what I have defined is pizza dot bracket equals to unit. Okay, that means this block of code will return an unit. I mean, that has not there is no return type for this. Okay, so what I'll do is it will return an unit. So it's not like entirely a return type, it's just a unit that has been written. It's a specific type of return type. Okay, so what I'll do is I'll create a pizza class, I mean a pizza object, and after that I will call is dot builder. See, whenever we are calling the builder, it is coming as a unit function, and after that, whenever it is building, what I'll do is I'll do pizza dot build function that I'll call. Okay, now this, we have defined the domain specific language. Okay, we have created the DSL pizza dot bracket, and the given the what this function will do, this will create an unit, and this is how we have defined the domain specific language here. What I'll do is I'll try to call it, and I'll show that how this domain specific language you can use whenever you're calling from the, suppose you have written this entire class and you are releasing it, so somebody has to use it, right? So whenever you use it using it, you just suppose you are using it inside the main function. So what you'll do it, suppose I'll create Okay, my pizza, and I'll call the pizza. And as you can see, I am getting all the chain methods that I have defined. Okay, so this has enabled me what? This has enabled me to use all the methods that I have defined inside it. As you can see, this is coming the add to topping as well. So in the add to topping, suppose I say cheese. I say add to topping again because it is appending this. What I'll do is I'll say onion. Okay. So you have used the domain specific language here. Now what I need to do is I need to do it's my pizza. So whenever you're calling this my pizza, it has been initialized with these functions and these values, that the chains that we have been initialized. We have initialized these chains, and after that, what it's calling is whenever it is being initialized, the builder will call this particular unit code, and it will initialize with large, and it will append to the toppings mutable list that we had defined. And after that, the builder will be chaining this, and whenever we will do that, we will see that this type of strings, the formatted strings, will come. Okay, now let's run it. Let's see. Yep, as you can see, the size has been initialized with large, and the toppings has been initialized with cheese and onion that we have been defined. I mean, we had declared that. Okay, so first we have gone through the Kotlin DSL and how we can use it. So Kotlin DSLs are made possible by some of the unique languages features like extension functions, okay, the lambda, that is the enable the use of this to refer the contextual object, and this is useful for creating expressive and human readable methods, so you can define everything on your own rather than writing everything verbose. And simplify method calls for DSL. Okay, so these features will combine to allow you to create natural, readable, and concise code for DSL. So suppose you're wondering that what these things are. We don't need this. We need something meaningful. So for that, let's create another one where we will do something meaningful. Okay. So I'm removing it, and we will follow the exact same format that we previously did. So for that, we will do is we will create a server config. Okay. Server config. And for this one, what I'll do is I'll create a host, and the host I will define as a string, and by default I'll take it as a local host. Okay. So I'll take a variable port as well. Okay. And I'll take it as an int, and I'll do is 8080 I'll define for the time being. And let's take a private val endpoints, and I will be taking a mutable list of strings. Okay. Okay, so this is completed, and after that, what I'll do is let's the previously what we did is we did appending, so we will do the same things. Let's create a method called function endpoints, and what I'll do is I'll take endpoint, okay, as a string. And what I'll do is I'll do endpoints dot add. Here I will add the endpoint, okay. And after that, what I'll do is I'll create a build method that will build this. And after building, what it will return a string, okay. And here we will use the interpolated strings. That is the, suppose it will return as server config, and I'll take is host is equals to host, okay. And the port will be port, endpoints will be endpoints, okay. So this is completed, okay. Now what I'll do is I'll create the builder, okay. What I'll do is I'll create the builder. Suppose I will do server config, and in the config I'll take server config dot. This is how we define the domain specific language, and I will do is unit, and in turn what it will return is a string, okay. Now what I can do is I'll take a variable called server config, and I will initialize the server config here. And after that, server config, in this object we will call the config, okay. And I will return the same thing, that is return server config dot bin, okay. So this has been, we have defined the basic use cases for a server config that requires, that has a host, that has a port, and the list of endpoints that it would require. And in the build script, what we have defined is that the currently initialized uh, host, port, and endpoints will be shown. And in the server config builder, what we are defining is we are creating a configuration class that will define the domain specific language, that this will be initialized with the server config, and we are defining the configurations. And in whenever we are returning, we will be giving a build, okay. So whenever we are using it, what I can do is I'll create a config, okay. I'll do is server config, and in the server config, what I can do is I'll do host equals to 192.168.1.1, okay. And in port, what I'll do is I'll do 9090. And in endpoints, what I can do is I'll do, suppose I give a login and endpoints, what is that, endpoints, what I can do is register, okay. I need to change this because, yeah, there are verbally incorrect, yeah. So whenever we do that, that it has, the configuration has been initialized, and now I'll print the configuration, okay. So what it will print is the, as you can see, it has printed all the host names, port, and the endpoints. So this is a proper use case that you have seen, that we can create a server config, and it we can create a, concise readable code, okay. So before we wrap up, let's quickly recap the advantages of Kotlin DSLs, okay, where you can use them. So first is increased readability. So as you have previously seen, that it is it has increased the readability of the code. The domain specific focus is also there, and the reusable and modular design. And some of the use cases that you will feel that, it's the best to go with, that is the build tools like Gradle, configurations management, UI designs, you know, writing tests or creating mock data. Okay, this is very much easy for that. So, that's a wrap on the Kotlin DSLs. We have explored that, what DSLs are, why they are particularly useful, and how to create your own using Kotlin. So, if you find this tutorial helpful, give it a thumbs up and subscribe for more Kotlin content. Don't forget to hit the bell icon so that you are notified for my next video. Also, let me know in the comments that what kind of DSLs are you planning to build. Until next time, happy coding. Thank you. Bye.